So in this video, we're going to go over accuracy and precision. So the first part of it states that accuracy of a number refers to the number of significant digits it has. So if we compare two numbers and we count the significant digits for each number, the one that has the more significant or the most significant digits is going to be the most accurate. The precision of a number refers to the decimal position of the last significant digit. So we're looking at the place value of that last significant digit, and then we're going to determine whether the further you go as far as place value or the decimal position is going to be more precise. If the problem or the two numbers don't have a decimal, then we're just going to choose the smaller of the two numbers. And we'll get into some examples so I can show you what I mean. So here we have two numbers, 0.312 and then 0.31. So looking at both of these numbers, I know that this one number is more precise as this one. Why is that the case? Because if I look here, I have tens, hundreds, thousands, and this one here is just tens, hundreds. So since the last digit represents thousands for this one, and the last digit represents hundreds for this one is more precise than this one. Now if we're going to the accurate part, if you notice here, how many significant digits is this one? Well, you should say 3. 1, 2, 3. How many significant digits does this one have? This one has 2. So because, again, we're looking for that more, this one has more significant digits than this one, then this is going to be more accurate as far as the number. So look at some more examples. So 341 is more accurate than 0.08. Again, how many digits does it have? This one has 3. Over here should have 1 because the 0 is not a significant digit because it's just placeholder until we get to the 8, which is significant. So we have 3 versus the 1. That's why this one is more accurate than this one. However, if we're talking about precise, 0.08 is more precise than this one because if you look at the decimal place in here, tens, hundreds, the hundreds is more precise than, well, this one doesn't have any as far as the significant decimal places. So if I have 1200 and I have 4000, well, this one is more accurate than this one because guess how many significant digits is here? 1, 2. Remember, these zeros are not significant. So it's just 1, 2. These zeros are not significant, so it's just 1 here. So 2 is more accurate than the 1 significant digit. Precise, well, they don't have any decimals here, so we can't count decimal place values. However, because the numbers don't have any place value, we just pick the smaller number, which is 1,200 is more precise than the 4,000. The next part we want to get into is rounding. And we probably remember before, if the digit is 0, 1, 2, 3, 4, we look to the left and say that that number will remain the same. It does not go up 1 because when we're rounding, it has to be 5, 6, 7, or 8, or 9 for it to go up 1 unit. So we look here, I want to round both of these numbers here to 3 significant digits. If you look here, how many significant digits we have so far? 1, 2, 3, 4. All these are considered to be significant because the 0 in between 2 significant is considered to be significant. So I need to go from 4 significant digits to 3. Well, if I look here, this is 1, 2, 3. So I know I'm going to require these 3 numbers here. So this 5 is going to make this 2 go up 1 because the 5 or greater will make a unit go up 1 or digit go up 1. So that's why I get my 2 here. I don't want to, you can't just drop off the 0 and make it here because you have 2 different numbers. So you can't say the answer is 202 because that's not the same as this one with it. This is 2015, or this needs to be 2020. So the only way to make it 3 significant digits is to make this last one a 0. So I have 1, 2, 3 significant digits, which is 0 is just a place value, so we can just kind of not count it as significant digits. So that's my 3. Here, I know, I have 4 significant digits. 1, 2, 3, 4. These 2 zeros are considered to be significant because it's in between 2 significant digits here, 3 and the 4. Remember, I want to make it 3, though. So I count 1, 2, 3. So I know I need to include these 3 because we go in order. But the 4 is what I don't need. So the 4 is what I'm going to use to see if this one goes up 1 or stays exactly the same. Because it's a 4, it's going to stay the same. If it was a 5, then it would be 3, 0, 1, but it's not, or 6 or 7. But since it's not, it's a 4, that's going to remain the same. So we have our 3 significant. 1, 2, 3. Remember, zeros after a significant, after the decimal and significant, are considered to be significant. So that's why we have 3 significant digits there. The last thing I want to go over is when we're doing our computation, we're adding, subtracting, dividing, or multiplying, we need to express our answers a certain way. And this is the layout of how we're going to do that. When adding, subtracting, we're looking more at the result of the decimal. When multiplying, dividing, we're looking for more of the accuracy. So decimal precision, looking at that decimal over here. Accuracy for multiplication and division, we use the significant digit part. And then for if it's multiple steps, if you have and you have a big problem that has a lot of addition, subtraction, multiplying, and dividing, we're just going to go by the place value as far as how many digits are after the decimal. So here's some examples. So notice that we're adding, and because we're adding, I see there's 1 place after this decimal. There are 3 places after here, and there are 2 places after here. So once I finish adding them together, I get this is my answer. So how am I going to express my answer? Well, because this one has the smallest one, as far as placing after the decimal, this is going to see what my answer should be as far as adding and subtracting. So I should have 1 place after the decimal, because it's the smallest one. Remember, we want the most precise. Here we're dividing, so we're looking for the most accurate. So for accuracy, I have 2 here and 3 here. So this 2, because it's the smallest here, is what my answer should be when I get over here to the end with it. So significant digit 1, 2, 1, 2, 3. This is my 2. So I get this long drawn out number, but I'm going to stop it here. Remember, this 0 is not considered to be significant. Only these 2 on the end. So I have 0.059. Here I have multiplication. So I have how many significant digits here? 1, 2, 3, 4, 5. I have 3 here. Because this is a 3, I want my answer. I don't want all this number here. I want my answer to have 3 significant digits. So if I look at this problem here, 1, 2, 3, these are my significant digits that I need, but this 9 is going to make this go up, to 1 with it, and the rest of them become 0. So that's why I get 16,900, because this 8 went to a 9 because of the 9 here. So here we have what was called the multiple parts. We have some subtraction, and then this side by side here means multiplication. So I have 1 here, 3 here, 3 here. Because of this 1 is my, the least one is the one I'm going to use as far as my final answer. So once I do all the computation, I get this answer. But however, we only need 1 place after it. So this 8 will make the 4 go up to a 5 because I only want 1 place after the decimal. Here we have a bunch of things going here. We have some multiplication divided by some subtraction. Well, I'm only concentrating on this 3 because of the place after. So I have after this decimal is 1, 2, 3, 1, 2, 3. So once I get down to my final answer, we have this long part here. I'm looking for just these 3 here, 1, 2, 3. So if this is just my 3, this 6 is going to make the 5 go up 1, and that's why I get 1.3